Okay, so I'm going to be showing the first part of the um the first part of the uh code that I've written so far. So like basically like I said, like I mentioned the last time, um the design has already been done. So what I want to do now is to translate the mental design to the physical implementation. So like I mentioned that we have three stages of development, or the three stages sub layers. We have the presentation, the session, and the gateway stage, right? Now, this okay, let me just quickly show the stages. So I open up. So let me start from the gateway stage. So this gateway basically, as the name implies, is the interface between the protocol and the outer layer, that's the UDP in this case. So it's in charge of sending and receiving data. That's the most primary function of this gateway stage. But however, you want because this is a multi-path, uh, or this protocol enables multi-path, uh, like you will be able to send your messages on multiple interfaces, right? So let's say you have I already have something like that here just to demonstrate. So you have uh, an application, right? And then it's the server in this case, and you also have another application, the receiving application. Okay, so that okay. Let me just quickly grab this. All right, so um, let's see. So you have these two applications, and then uh, you want to send a particular number of messages across. So you want to send a particular window of messages. So w- assuming you have two interfaces, you want to be able to utilize both of them. So here you have your Wi-Fi card and your internet. So utilizing these two is basically what multipath is, meaning I can take a particular capsule of data, send it through one interface, and I can take the next one and send it to the next interface. Of course, they have to be available and connected to the network for you to be able to utilize them. And then likewise on the receiving end, you can also receive on those two interfaces and then forward that capsule of data to the process uh, in question. And yeah, so but it's not necessary that both participants have to have the same amount of interfaces. You can have just one, but then the higher the better, basically. So yeah, so that is the job of the gateway to make sure that works seamlessly. And then we also have a timer. So you're going to have different types of timing objects. So you want to time okay, I'll get back to the timer. And then you have the processor basically to help you to it's basically a helper class basically to help you process uh buffers and header information. So you have your send, like I said, send, receive. Now, one more thing to mention here, there's a difference between this receive function and a send function or pull function rather. So like the receive at the beginning is your when the uh TX is listening for connection basically. That's basically what it means. So like you're expecting like uh any client basically to connect to the port. And then once that client is connected, you can then uh, begin to send data across. So that stage of listening for connection is different from when you are pulling data from the destination. So a pull is basically like I'm saying, okay, I want to. The the major difference is one is related to uh actual data information. The other one is basically like the connection setup uh mechanism. So yeah, I think that's all I want to say about the gateway. So next is the session, uh, and then the session is basically this layer that handles connections and manages them, their setup, their breakdown, and maintains them. So basically, this is where you begin to introduce the state. So this can be the whole system can be modeled as a state machine, and then you have different states, right? And then there are transitions between states depending on the input. So your inputs are your capsule headers. Sorry, not capsule, not the capsule header. Your inputs are like the capsule that you send or receive. So, for example, when you're in an open state, or let's just go through each and every one of them. So, at the beginning, okay, I'll come back to that. So, you also have the processor to help the session process data. So, you set some of the functions or some of the methods rather set header parameters, basically like to set because the session is the layer that sets most of the header values. So you want to be able to okay, so the this class helps to set those values depending on the states that we are on currently. And then process is basically like you're processing a capture that you receive. So the first one is for what do you call it? First one is for outgoing data. The second is for incoming data or inbound data. So now in the session class, you have what's the direction? Are you the client or the server? You have the states. Then you have some flags to signify that you're done or not done, basically. And so the first method is this start. So what the this is what you call to start the whole uh to start the session. And then when you start, you first check whether you are the current state is done, whether you're in the done state. If you're done, then you proceed back to the connected state. Uh, but however, if you're not in the done state, then we just go through each and every one of those states. Okay, so the first state is the open state, right? So let me quickly go to the open state. So the open state is basically when you are open for connections, right? So now both uh the sender and the receiver have the same number of states, but the operation on every state is different. So what they do in each state might differ, but they have the same number of states. So they are both in an open state, they are both in a setup state, and so on. So for the TX guy, the setup state is basically you listening for like a hello message to say, okay, is anyone out there? And then uh you process you process that message and determine if it is the right message before you respond to it. The RX guy is the one sending the message in the first place. So that's uh, kind of the difference between both. But they are both in an open state, or they both start from an open state and then proceed to the next state, which is the setup state in this case. So in the setup state, you have the sender, or yeah, you have the TX. Let me just use. I'm using TX for like server, RX for like the receiver for the client, just to kind of shorten the number of words. So so the compositor is basically like the first layer that kind of gives us buffers that we need if we need one, and then we create a new one, set the header parameters, and send it. So this sets header parameters in this case checks the state and says, okay, we're in the setup state. Therefore, the parameters would be like a high response. Okay, and then we send. Uh, Likewise on the RX end, I'm just receiving because I'm expecting a response to the request that I sent. So, so this setup state is basically like the handshake in TCP terminology. So another thing I do here is this is where I send the interface information, right? So the extra interfaces that me as the TX can have, I send it and forward it here so that the RX can be able to communicate and set up connections on those interfaces as well. But the main interface still remains uh, still remains active. So once we are done setting up, then we proceed to the connected state. And the connected state is basically when we are saying, okay, now we are connected, we're on the same page, we are about to proceed for communication, but the I have to expect like an acknowledgement from you that everything went well. So the TX is the one expecting the acknowledgement in this case. The RX is the one sending that acknowledgement. Now the acknowledgement serves as for two purposes: acknowledging the previous data that was sent, but also initializing or sorry, kicking off the start of the data transfer, actual data transfer, because up until now we haven't sent any data yet. All right. So once we are done with that, then we come to the closed state. So the closed state is basically when we are saying we are kind of locked in, and these two participants are are about to send data, or yeah, about to send data between each other. So in every uh there's a window size of data. So like I showed you, you have a particular window. So this window contains one, two, three, four capsules, right? So I send what the window means is that I'm sending four of them before I'm expecting like the verification and acknowledgement to say okay, everything went well. Okay. So now this window size is advertised by the RA. Say okay, this is what I can receive. Um okay, so yeah. Uh So once I send that amount of capsules, right, I then proceed to the done state. Or once I receive the amount of capsules, if I am the RX, I proceed to the done state. And then as a TX, I'm expecting the control okay. So an okay basically means okay, I got everything correctly. Okay, so you don't need to retransmit. Now we are going to be. I've not started at the error handling uh functionality. So not error handling in terms of like fixing bugs, but like in terms of error in transmission and mistakes in like maybe something went wrong somewhere. So uh, you want to be able to account for that. So yeah. So once we are done, so that's basically it. And then in the send states, because both of them, all of these states are calling an internal state, which is the send and receive state, and all that does is basically send and you uh, receive data. Yeah. So finally, I'm going to talk about the presentation, and that's the compositor stage. For now, it's a bit scanty because uh, I'm focused on the other two stages. But basically, it's made up of a compressor. So, like, you want to be able to compress data. Now, compression is not mandatory because in some cases, when you're sending like control information, you don't need to compress 2 bytes of data, or rather, like 10, 15 bytes of data. That's basically a waste of time. But let's say let's say there's congestion in the network, and let's say there is a large amount of data to send. So that way, compression might be of help. So this compressor class is basically a helper for the compression and decompression uh, functionality. Now, I haven't mentioned the factories. So the data factory is basically an abstraction of the data where, okay, so this, uh, so in the diagram, right, so you have an involved chain. So this chain of data is basically running through the whole stages or the whole segment or the whole layers. So and every uh every host that's either the RX or the TX has exactly two of these. So one is for the receiving and the other is for sending. So when I'm receiving data, I'm receiving it into one of the factories, that's the RX factory, and then the second one is the TX factory that helps me to uh so the TX factory basically is to is connected to the source. So the factory is different from the source. The source of data might be like a file, might be like uh it could be anything, but like it's a factory that helps to process that data, not process it in the sense of like presentation layer as well,